Hello students, welcome to class 12 physics. In this video we are going to discuss about the electrical energy when an AC current passes through a resistor of chapter number 7, alternating current. Now we had already discussed about the voltage that is applied to the resistor, right? Because we are talking about the AC voltage, the voltage will be equals to Vm sine omega t, because it is changing periodically with respect to time, and the current is I equals to Im sine omega t. So this we have already seen. Now it is seen from the graph that in AC circuit voltage and current varies with sine curve, and obtained positive and negative values correspond to it. Thus, the sum of the instantaneous current values over one complete cycle is 0 and the average current is 0. So, when we take the current values, right, for the whole cycle, then here in the positive half cycle, all the values are equal to that of the negative half cycle, but in the negative direction. So when we sum up these values, it will be 0. So the sum of the instantaneous current values over one complete cycle is 0 and the average current is 0. That means when we take the summation of all the current values up for one cycle, it will be 0. The fact that the average current is 0, however, does not mean that the average power consumed is 0, and that there is no dissipation of electrical energy. So here current is equals to 0, that does not mean power is also equals to 0, because see here in this equation, when we take power as P equals to I square R, right, and if we take the current value as 0, then the power should be 0, but it is not so, because power is always consumed and there is some dissipation of the energy. Joule heating is given by I square RT and depends on I square, which is always positive, whether I is positive or negative, and not on I, right? So I value, that means the value of the current in the positive direction of the or the value of the current in the negative direction. But when we take the square of this current value, then its value will always be positive. Now, the instantaneous power dissipated in the resistor is P equals to I square R. And we know I equals to what? That is equals to Im sine omega t. So, we can write it as Im sine omega t whole square into R. So, squaring this whole term, we get Im square into sine square omega t into R. So this equation becomes Im square R sine square omega t. Now the average value of this power over one cycle, it is, we know that this is the symbol for average. So average for power is equals to taking the average on both the sides, that is average of power is equals to average of I square R, and we know that I square R, that is equals to Im square R sine square omega t. We need to take average of this, but in this case Im square and R both are constant. So taking that outside, we need to take average of sine square omega t. So here P equals to Im square R average of sine square omega t. Reason, because Im and R is constant. Now using the trigonometric function, that is the average of sine square omega t, we know the equation that sine square theta is equals to 1 minus cos 2 theta by 2. So here instead of theta we are having omega t. So we can write sine omega t equals to 1 minus cos 2 omega t by 2. So, and splitting this, we can write sine square omega t equals to 1 by 2 minus cos 2 omega t by 2. So we can write like this: sine square omega t equals to 1 by 2 minus 1 by 2 cos 2 omega t. So here taking the function of that is, we know that average of the function that is equals to 1 by t integration from 0 to t function dt. This is the general equation. Now here we are having, instead of this function, we are having sine square omega t equals to 1 by t integration from 0 to t function we are having. We need to write this equation, so that is 1 by 2 minus 1 by 2 cos 2 omega t. So here we can write it as sine square omega t equals to 1 by t integration from 0 to t 1 by 2 minus 1 by 2 cos 2 omega t dt. Now splitting these terms, the first term and the second term, we can write 1 by t integration from 0 to t 1 by 2 dt minus 1 by t integration from 0 to t cos 2 omega t by 2 dt. Now taking 1 by 2 outside, that is 1 by 2 t integration from 0 to t dt minus taking this 2 outside, we get 1 by 2 t integration from 0 to t cos 2 omega t dt. So this first step becomes 1 by 2 t, this integration derivation get cancelled and we are having just t, that is 0 to t minus 1 by 2 t integration of cos 2 omega t will be sin 2 omega t divided by 2 integration from 0 to t. So here the first step will be 1 by 2t by 2t t minus 0, so t gets cancelled. This first term will be half minus 1 by 2t over here sin 2 omega t. So let us write the first step again. First equation we are having 1 by 2t t minus 0 and then 1 by 2t sin 2 omega t by 2 0 to t. Taking this t gets cancelled, we are having half minus 1 by 2t. Now putting small t as capital T, so that will be, and taking this 2 outside, it becomes 4 and here sin 2 omega capital T minus sin 0, that becomes 0. So next step will be 1 by 2 minus 1 by 4 into, here omega, instead of omega we can write 2 pi by t. So that becomes sin 2 into 2 pi, that becomes 4 pi by t into t minus 0. Thus t gets cancelled, we are having sin 4 pi. So sin 4 pi, that will be 0. So equation becomes 1 minus 2 minus 1 by 4 into 0. So it will be 1 by 2. So the average of sine square omega t, that will be half. So now substituting that over here in this equation of average power, because average power is equals to Im square r average of sine square omega t, and we know sine square omega t, that is half. So writing that, we get P equals to half Im square into r. So we get the value of this average power. So students, you may note down this theory.